Hello everyone, good evening. Okay, we shall solve some more KCET previous year questions for three-dimensional. First part of this video, we shall start from one. So any doubts if you have in any of the steps, please write us in the comments. Let's clarify them in subsequent videos. And in any other chapter of maths, if you feel more difficulty, and also mention the name of that chapter in the comment section. And we shall give more priority on it for more and more questions on that chapter. And also some important questions will be uploaded in the Sapience education application. So please install our Sapience education application. This link has been provided in the description. So in the question number 1, it's told the distance of the point P, A, B, C from the x-axis. So if we draw a perpendicular, we draw a perpendicular on the x-axis from the point P. Let's say it's the foot of that perpendicular from the point P. So the coordinates of the point M will be 0, A, 0, 0. Therefore, the length PM is the required distance. Is the required distance of the point P from the x-axis. So it will be equal to square root of b square plus c square. Option B is the correct answer. Then question number 2 says that equation of the plane perpendicular to the line, equation of the plane perpendicular to the line is and passing through the point 2, 3, 4 is equation of the plane that is perpendicular to this line passing through the point is. So therefore the normal vector to this plane, here we have a plane, here we have a line. So this line is perpendicular to this plane. So the normal vector to this plane, that will be, let's say, it is same as the direction ratio of the line. Line is y1 equal to y by 2 equal to z by 3. So its direction ratios, the direction ratios of the line is 1, 2, 3. That means that n vector, which is the normal vector to the plane, that will be also along the direction ratios of the line. That will be equal to I cap plus 2j cap plus 3j cap. And so the plane also passes through the point A, is 2, 3, 4. So therefore we can write the equation of the plane as r vector minus a dot n, where r vector is xi cap plus yj cap plus zk cap, which is the position vector of any point on the plane. A vector is the position vector of the point A. A vector is the position vector of point A, which is 2i cap plus 3j cap plus 4j cap. R minus a dot n means that x minus 2 I cap plus minus a vector is x minus 2 I cap plus y minus 3 j cap plus z minus 4 k cap, then its dot product, if you take its dot product with the n vector, that is I cap plus 2 j cap plus 3 j cap, that is equal to x minus 2 plus 2 into y minus 3 into z minus 4, that is equal to 0. Therefore I can say that x minus 2 plus 2y minus 6 plus 3z minus 12, that is equal to, therefore I can say x plus 2y plus 3z is equal to 8 plus 12 plus 20. Option D is the correct answer. And question number 3 is, the line this is parallel to which plane? So if the line is parallel to the plane, suppose if the line r vector equals to a vector plus lambda b is parallel to the plane, r vector not n vector equal to t, suppose, then we should have b vector dot n vector. Since why? Suppose we have a plane, then n vector is the normal vector to the plane, and if a line is parallel to this plane, then this b vector is the direction ratios along the line. B vector represents the direction ratios of the line. So it means that this b vector should be perpendicular to the n vector. B vector should be perpendicular to the n vector. So therefore, the scalar product of b and n that should be 0. So now here the equation of the line is given as x minus 2 by 3 equals to y minus 3 by 4. So here the b vector, which is the direction ratio of the line, that is 3 I cap plus 4 j cap plus 5 k cap, and so I can say that so in the option C, the equation of the plane is given as 2x plus y minus 2z, that is equal to 0. So here the normal vector to this plane, that is 2 I cap plus j cap minus 2 k cap. So now b dot n, that is how much? 2 3 are 6 plus 4 minus 5 to the 10, which is equal to 0. Therefore option C is the correct answer. It means that this plane is perpendicular, this plane is parallel to this given line. Then question number 4 says that the angle in between two diagonals of cube is So let's say one of the vertices of the cube is the origin, that is 0, 0, 0, 0. And the other end, that will be a, if the length of each side is a units. So then suppose this point is x-axis, This edge is x-axis, this edge is along the y-axis, this edge is along the z-axis. Therefore, the coordinate of this point will be 0, 0, 3. The coordinate of this point will be 0, sorry, this is a, 0. Let's say, so this is point O, this is suppose A, this is B, this is C. Therefore, the vector OB is one of the OB vector and AC vector. OB vector and AC vector are along two diagonals. Okay. So where OB vector, that will be equal to A into I cap plus J cap plus B, and AC vector is equal to C vector, is OC vector, which is A K cap, minus this is, so it is OC minus OA, that will be AI cap plus B cap. So then minus AI cap minus AG cap plus. Now OB vector into is O vector, OB vector dot AC vector. OB vector dot AC vector means you have to find the scalar product of OB vector and AC vector. So that will be equal to, so this is A into minus I cap minus J cap plus B cap. This will be A square into I cap plus J cap plus K cap. It's dot product with minus I cap minus J cap plus K cap. OB dot AC. A square into I into minus I cap dot minus I cap, that is minus 1, then plus J cap into minus J cap, that is also minus 1, plus K cap plus K cap dot K cap, that will be plus 1. So 1 that will cancel out, minus K square. Then therefore the angle in between these two diagonals, that will be equal to cos, if that is theta, then cos theta I can say. This is, so if you want to find the acute angle only, you have to take the mod of OB dot AC divided by magnitude of OB to magnitude of, so that will be, it is mod of minus A square divided by magnitude of OB, that is square root of A square plus A square plus A square, that is root 3A. So 3A. So this will be 1 by 3. Therefore the angle theta is cos inverse of 1 by 3. So here theta is only the acute angle in between the two diagonals of the cube. This is the acute angle in between the two diagonals. Option A is the correct answer. Is the correct answer. Then in question number 5, it's told that the lines, these two are coplanar. if two lines are coplanar, if they lie in the same plane, then we should have, then it means the distance in between the skew lines should be equal to, we have to use the rule, the distance between the skew lines, that should be equal to, any two straight lines if we have which are neither parallel nor intersecting, so then the distance in between these two straight lines d, that is given as mod of a2 minus a1 dot b1 cross b2 divided by magnitude of b1 cross b2, magnitude of b1 cross b2. This should be equal to, it means what, that the value of a2 vector minus a1 vector dot b1 cross b2 should be equal to 0, where the equation of the line L1 is, suppose r vector equals to a1 plus lambda b1, and the equation of the line L2, is r vector equals to a2 plus lambda b2, a2 plus mu b2. Therefore here the line L1 is given as x minus 2 by 1, that is equal to y minus 3 by 1, that is equal to z minus 4 by minus 3. So therefore b1 vector, that is equal to I cap plus j cap minus k cap, and the equation of the line L2 given as x minus 1 by k is equal to y minus 4 by 2, that is equal to z minus 5 by 1. So therefore I can say that b2 vector that will be equal to k I cap 2 j cap plus k cap. Here a1 vector, that is also equal to 2 I cap plus 3 j cap plus 4 k cap. Since why, from here we can see that the straight line passes through the point 2, 3, 4. Here also this straight line L2 passes through the point 1, 4, 5. A2 vector is I cap plus 4 j cap 5 k. So therefore a2 vector minus a1 vector, that will be equal to I cap plus 4 j cap plus 5 k cap minus a1, that is 2 I cap plus 3 j cap plus 4 k cap. So this will be equal to I cap minus 2 j cap cap minus 2 I cap, which will be minus I cap, plus 4 j cap plus 3 j cap, so it is plus j cap, and plus 5 k cap minus 4 k cap, that will be minus k cap. And b1 vector, that is I cap plus j cap minus k cap. b2 vector is k I cap plus 2 j cap plus k cap. So now, therefore, a2 minus a1, we have to find the scalar triple product of a2 minus a1 and b1 vector and b2 vector. a2 minus a1 dot b1 cross b2. That will be equal to the determinant of minus 1, 1, minus 1, minus 1, plus 1, 1, 1 minus k, and this is k to 1. That should be equal to 0. Then we have to find the value of, therefore from here we get minus 1, 1 plus 2k minus 1 into 1 minus 1 into 1 plus k square plus 1 into 2 minus k is equal to 0. So this will be minus 1 minus 2k minus 1 minus k square plus 2 minus k, that is equal to 0. Therefore 2 and 2 that will cancel out, k square plus 3k that is equal to 0. So k into k plus 3 that should be equal to 0. So k is either 0 or minus 3. Option D is the correct answer. And if in the option C it was minus 3, then option C also would have been correct. Then question number 6, for that 6 it has been told that let vector A is I cap plus 2j cap plus k cap, B vector is I cap minus j cap plus k cap, C vector is I cap plus j cap. Vector in the plane A vector, B vector, a vector in the plane A, B, whose projection on C is 1 by root 3. A vector in the plane of A and B whose projection on C, it means that any vector in the plane of A and B can be written as, suppose the vector A is equal to A plus lambda times B. This A is in the plane of A and B, whose projection on C is 1 by root 3. So it means that the projection of vector A on the vector C is A vector dot C cap. So it is equal to A vector dot C vector divided by magnitude of C. Now therefore C cap, that is equal to C vector by magnitude of C vector, is equal to I cap plus j cap minus k cap by the magnitude of C, that is square root of 1 plus 1 plus 1, that is square root of 3. And A that is equal to A plus lambda B 1 plus lambda 2 minus lambda B cap plus 1 plus lambda B cap. Therefore, A vector, here it is told A vector dot C cap that is equal to 1 by root 2. Which is given. Then we have to find the so we have to find that vector A. First, we need to find the value of that lambda. Value of this lambda we have to find first. A dot C cap is equal to 1 by root 3 1 plus lambda 2 minus lambda A dot C cap 2 minus lambda, then plus minus of 1 plus lambda should be equal to 1 by root 3. Should be equal to 1 by root 3. So these two will get cancelled. Therefore, this value should be 1. Therefore, I can say 1 plus lambda plus 2 minus lambda and this will be 1 plus lambda plus 2 minus lambda minus 1 minus lambda that should be equal to 1. 1 and 1 that will cancel. Then here we can see that 1 lambda and minus lambda will cancel. So this will be 1 minus lambda that is equal to 0. So lambda should be equal to 1. So therefore, the required vector A is plus lambda. This will be simply A plus B since lambda is equal to 1. So A and B, if we add them, then we will get 2 cap A cap 2 cap plus K cap, then this will be plus K cap plus K cap plus 2. So the projection, when you have to find, you have to take the mod actually. Take the mod of this. This is plus or minus 1. Wrong here. This one will get cancelled. This one will not get cancelled. So therefore, it is coming 2 minus lambda equal to plus or lambda will be equal to 2 plus or 1. It means that lambda can be 1 or it can be. Therefore, Therefore, it means that the value of lambda. Okay, then therefore the vector A can be A plus lambda. A vector is I cap plus 2j cap plus 2 plus lambda into B vector I cap minus j cap plus 2. Then therefore B vector can be either it can be 2 I cap. Suppose if we take lambda is equal to 1 at first, then we will get I cap 2 I cap plus j cap plus 2 p cap, and or we can also get A vector as here. If we put lambda is equal to 3, then we get I cap plus 4 I cap I cap plus 3 I cap, that is 4 I cap plus 2 j cap minus 3 j cap, that is minus j cap plus k cap plus k cap, that is plus 4 j cap. So here option D is the correct answer. Then question number 7, it is told the equation of the line passing through the point 2, 3, 1 and parallel to the line of intersection of the plane is, it is told to find the equation of the line that passes through this point A and it is parallel to the intersection of the of one plane with another plane. So therefore here the line of intersection of the planes, we have to find the line of intersection of the planes that will be given as this one, x minus 2y minus z plus 5 plus lambda into x plus y plus z plus 6, that would be equal to line of intersection of the planes. Planes be equal to 0. Line of intersection of the planes, if you have to find, then we can find the direction ratios of that line of, we have to find the direction ratios along the line of intersection of these two planes, which is B vector, that will be equal to n1 cross n2, where n1 is the normal vector to the first plane, that is the normal vector to the plane x minus 2y minus z plus 5, that is equal to 0. So that is nothing but I cap minus 2j cap minus k cap, and n2 vector is the normal vector to the second plane. So normal vector to the plane is given as x plus y x plus y plus 3z minus 6 is equal to 6. So that is also equal to I cap plus j cap plus 3. So therefore we have to find the equation of the line that is passing through the point 2 comma 3 comma 1, and it is parallel to this line of intersection of these two planes. So if this vector is b vector and this is point suppose this is point p, therefore the equation of that line will be in the form a plus lambda b, where a is the position vector of the point A. Is the position vector of the point A. Now first we have to find therefore the b vector, which is the determinant of I, j, k. Then we have to write the components of n1 vector and the components of n2 vector. So that will be 1 minus 2 minus 1, 1 minus 2 minus 1, and then the for n2 vector it is 1 1 3. That will be I cap into 3 is a 6 minus 6 minus of minus 1, that is not 1, minus j cap into 3 plus 1 is k cap into 1 minus of minus 2, that is plus 2. So this will be equal to minus 5 I cap minus 4 j cap plus 3 k cap. So therefore the direction ratios of the line are minus 5, minus 4 and 3. Therefore the equation of the line will be x minus, and this line is passing through 2 comma 3 comma 1, 2 comma 3 comma 1. So its equation is x minus 2 by minus 5, that is y minus 3 by minus 4, that is equal to z minus 1 by 3. So option A is the correct answer. Then in question number 8, we have to find the foot of the perpendicular that is drawn from the origin to this plane. Foot of the perpendicular that is from the origin to this plane by 1, that is given as 2x 3y plus 4z equal to 29. So suppose the foot of the perpendicular that is m is suppose x1 comma y1 comma z1. Then it means OM is perpendicular to the plane phi 1, and the normal vector to this plane, that is given as 2 I cap minus 3 j cap plus 4 k cap. OM vector is parallel to n vector. OM vector is parallel to n vector. So therefore I can say that OM vector is some lambda times n. Therefore OM vector is x1 I cap plus y1 j cap plus z1 k cap. That is equal to lambda n. So this is 2 lambda I cap minus 3 lambda j cap plus 4 lambda k cap. Therefore x1, y1 and z1 I can write, that is 2 lambda minus 3 lambda and 4 lambda. And since point M is the foot of the perpendicular on the plane, so point M lies on the plane itself. Point M lies on the plane itself. So therefore it should satisfy the equation. Therefore you can say that 2 into 2 lambda minus 3 into minus 3 lambda plus 4 into 4 lambda is equal to 29. Therefore I can say this will be 4 lambda plus 3 is a 9 lambda plus 4 for the 16 lambda, that is equal to 29. Therefore 29 lambda, that is equal to 29. Lambda is equal to 1. Therefore the foot of the perpendicular is 2 comma minus 4. Option A is the correct answer. Therefore here the vector equation of the plane, which is at a distance of vector equation of the plane, that is at a distance of 3 by root 14 from the origin, and the normal from the origin is that is 2 I cap minus 3 j cap plus k cap. That is how much. So suppose any arbitrary point, if I take here, this y comma z, any arbitrary point, then OP vector is R vector. This is the 3 by root 14 is the small t, I can say, which is the perpendicular distance of the plane from the origin. The perpendicular distance of the plane from the origin. So then this I can say that r vector dot n cap, that is equal to d. So r vector I can say that is x I cap plus y j cap plus z k cap. It is the position vector of the arbitrary point P. It is the position vector of the arbitrary point P. Position vector of P. N cap, that is equal to 2 I cap minus 3 j cap plus k cap. That divided by the magnitude of n vector. Now magnitude of n vector is square root of 4 plus 9 plus 1, which is root 14. Therefore r vector dot cap, that is equal to d, is 3 by root 14. So this, so if you take the scalar product r vector and n cap, that will come 1 by root 14 into 2x minus 3y plus z, and that is equal to 3 by root 14. So root 14 and root 14 will cancel. So therefore the required equation of the vector equation of the plane, is okay. So this is the scalar equation actually. It is 2x minus 3y plus z, that is equal to 3. So if we convert it into the vector equation, then we will have r vector dot 2 I cap minus 3j cap plus k cap, that is equal to 3. So option A is the correct answer. Question number 10 is find the coordinates of the foot of the perpendicular drawn from the origin to the plane. Now the plane is, its equation is 5y plus 8, that is equal to 0. And we have to find the coordinates of the foot of the perpendicular that is drawn from the origin to this plane. So let's say that is n. So the n vector, the normal vector to this plane, OM vector is perpendicular to the plane, So OM vector is parallel to the normal vector to this plane, it is n vector, and here n vector is equal to, and here you can write y is equal to minus 8 by 5. So this is simply, that is k cap. So that is j cap. Therefore OM vector, if the coordinates of the point M is x1 I cap, x1 comma y1 comma z1, then OM vector is x1 I cap plus y cap z1 k cap. That will be equal to, so it means that OM vector will be equal to some lambda times j cap, lambda times, so therefore I can say x1 will be 0, z1 will be equal to 0, y1 will be equal to lambda. If we put these values here, then we get, so 0 comma lambda comma 0 should lie on the plane, so it should satisfy the equation of the plane also. Satisfy the equation. Therefore we can say that 5 lambda, 5 lambda plus 8, that is equal to, so lambda should be equal to minus 8 by 5. So therefore the required coordinates of the foot of the perpendicular drawn from the origin to this given plane, that will be 0 comma minus 8 by 5 comma. Option D is the correct answer. In question number 11, it is told that the distance of the point, minus 2 comma 4 comma minus 5 from the line L1. Equation is given as x plus 3 by 3, that is equal to y minus 4 by 5, that is z plus 8 by 8. So let M be the foot of the perpendicular that is drawn from the point P on the line. So PM is perpendicular to the line L1. So if PM is perpendicular to the line L1, PM is perpendicular to the line L1, PM is perpendicular to the line L1. So let's suppose this one we take it as lambda. Then if the coordinates of the point x1 coordinates of the point M is x1 comma y1 comma z1, then we can tell x1 is equal to 3 lambda minus 3, y1 is 5 lambda plus 4, and z1 is 6 lambda minus 8. And this should and PM vector is perpendicular to line L1. So PM vector is perpendicular to the vector B also. But the vector B is the direction ratios along the line. B vector is the direction ratios along the line. That is 3 I cap plus 5 j cap plus 6 k cap. So therefore, PM vector dot B vector, that is equal to PM vector PM vector dot B vector, that should be equal to 0. So PM vector, that will be equal to x1 plus 2 I cap plus y1 minus 4 j cap z1 plus 5 k cap. That will be equal to x1 plus 2, if I do, this will be 3 lambda minus 1 I cap, then plus y1 minus 4, that is 5 lambda cap, z1 plus 5, if you do, 6 lambda minus 3 cap. And so PM vector dot B vector, PM vector dot B vector, that should be equal to 0. So therefore I can say that P lambda 3 lambda minus 1 to 3 plus 5 lambda into 5 plus 6 lambda minus 3 into 6, that is equal to 0. Therefore 9 lambda minus 3 plus 25 lambda plus 36 lambda minus 18, that is equal to 0. So therefore 25 plus 9, that is 34. 34 plus 36, that is 10, 70. 70 lambda, that will be equal to 70 lambda, that is equal to 21. Therefore lambda will be equal to 21 by 70. 7 3s are 21, so lambda is equal to 3 by 10. So we have to actually find the magnitude of the vector Pm, that will be equal to the distance of the point P from the line. Distance of the point P from the line. Yes, so then therefore vector Pm, that will be equal to 3 lambda, that is 9 by 10 minus 1 here plus 5 lambda, that is 5 3s are 15 by 10 j cap, 6 lambda, that is 18 by 10 minus 3, 18 by 10 minus 3 j cap. This will be equal to minus 1 by 10 I cap plus 15 by 10 j cap, 18 minus 30, that is minus 12 by 10 k cap. Therefore the magnitude of Pm vector, which is equal to the distance of the point P from the line, that will be equal to the magnitude of Pm vector, that is square root of 1 by 10 whole square plus 15 by 10 whole square plus 12 by 10 whole square, will be equal to 1 by 10, it is square root of 1 square plus 6 square plus 12 square, it will be equal to 1 by 10 into square root of 1 plus 225 plus 144. 144 plus 226. Plus 4 10 plus 4 6 7 70. This is root over 370 by 10. Square root of 37 by 10. Root over 37 by 10, that is C is the correct answer. Question number 12, it is told that the perpendicular distance of the point P from the xy plane. So at any point on the xy plane, the coordinates of any point is given as A, B, C. The y coordinate is 0. So the perpendicular distance of the point P from the xy plane will be equal to the, so if we draw the foot of the perpendicular from the point P on the xy plane, let's say it is point N, points P is 6, 7, 8, the coordinates of the point M also will be 6, 7, 0. So therefore, the length PM is equal to 8 units. So option C is the correct. So here in question number 13, it is told the plane makes an angle sine inverse alpha with the x-axis. So the x-axis, so the unit vector along the x-axis is I cap, and here is the plane, suppose. So the normal vector to the plane is suppose n vector, that will be given as 2 I cap minus 3 j cap plus 6 k cap. How much angle the plane makes with the x-axis, let that be alpha. So then the angle that the normal vector to this plane makes with the angle that the normal vector to this plane makes with the x-axis, that will be 90 degree minus alpha. So therefore this so we have to find the value of this alpha. So I can say that sine means cos 90 minus alpha, cos 90 degree minus alpha, it will be equal to n vector dot I cap divided by the magnitude of n vector dot I cap divided by magnitude of n. Therefore, the magnitude of n vector, that is equal to root of 2 square plus 3 square plus 6 square, that is equal to square root of 4 plus 9 plus 36 square root of 49, that is 7. And n cap dot n vector dot I cap, that is equal to 2. So therefore, cos 90 degree minus alpha, this is equal to 2 by 7. So it is also equal to sine alpha. So sine alpha is 2 by 7. Therefore, sine alpha. So here actually the question was wrong. It should be sine alpha. Sine alpha. Option B is the correct answer. So hope you have understood the solutions of each of these 13 questions. So in the next part we shall solve from question number 14 onwards. Any doubts if you have in any of the steps in these 13 questions, then please write that in the comments section. And also install our Sapience education application, where we shall upload some important questions on KCET. Thank you everyone.